Voyager 1 and Voyager 2, already covered in our spacecraft video, these twin probes earn a final mention here because they are the only human-made objects to have actually reached interstellar space. Voyager 1 crossed the heliopause in 2012, Voyager 2 followed in 2018, and both are now drifting through the space between stars, sending back the first direct measurements of interstellar plasma ever recorded. As of 2025, Voyager 1 sits about 163 astronomical units from the Sun, while Voyager 2 trails at about 141, both still transmitting after nearly 50 years. Neither is headed toward any particular star. They will simply wander for millions of years, carrying a golden record of human sounds and images that may outlast our entire species long after their power runs out and they fall permanently silent. New Horizons. After its historic flyby of Pluto in 2015, New Horizons continued outward and is now on a trajectory that will eventually carry it into interstellar space as well, though it will never catch up to either Voyager. It is currently traveling at about 13.7 kilometers per second, slowing gradually as it climbs out of the Sun's gravity well, and it will likely take much longer than either Voyager to actually reach the heliopause given its slower escape velocity. Scientists are using its position in the outer solar system to make unique observations impossible from Earth, including studying the faint glow of the universe's background light from a vantage point free of the interference caused by sunlight scattered through our inner solar system. Pioneer 10 and Pioneer 11. Launched in the early 1970s, these were the first spacecraft to be placed on trajectories that would eventually carry them out of the solar system entirely. Both carried a golden plaque designed by Carl Sagan showing a man, a woman, and a map back to Earth, the first physical message ever sent toward the stars. Contact was lost with both probes decades ago, long before they reached interstellar space, but they continued drifting silently outward, carrying humanity's first handwritten letter to whomever might find it. Pioneer 10 is heading in the general direction of the constellation Taurus and would take over 2 million years to reach the nearest star along its current path, assuming nothing ever intercepts it first. Project Daedalus and Project Icarus. Long before breakthrough Starshot, in the 1970s, a team of British scientists and engineers spent 5 years designing one of the most detailed interstellar spacecraft concepts ever produced, a fusion-powered probe intended to reach Barnard's star, nearly 6 light-years away, within a single human lifetime. Project Daedalus would have been built in orbit, stood taller than most skyscrapers, and burned through fusion fuel pellets ignited by electron beams to accelerate to roughly 12% the speed of light. It was never built. The fuel it required does not naturally exist on Earth in usable quantities, but the design proved that interstellar travel was not pure fantasy, just an extraordinarily difficult engineering problem. In 2009, a non-profit group called Icarus Interstellar revived the concept under the name Project Icarus, updating the original design with modern material science and propulsion theory. Neither project has ever launched a spacecraft, but both remain foundational blueprints that every serious interstellar mission concept since has drawn from. The E-sail. While laser sails like Starshot dominate the public imagination, a quieter and arguably more practical concept has been gaining attention among propulsion researchers: the electric solar wind sail, or E-sail. Rather than using light pressure or chemical fuel, an E-sail would deploy long, thin charged wires that interact with a stream of charged particles constantly flowing outward from the sun, the solar wind, using that interaction to generate thrust without needing to carry any propellant at all. Calculations suggest an E-sail could potentially achieve speeds of 20 to 30 astronomical units per year, multiple times faster than Voyager 1's current pace, using nothing but a structure of wires and the sun's own particle wind pushing against them. It would not get anywhere near another star within a human lifetime, but it could dramatically shorten the time needed to reach the outer solar system and the boundary of interstellar space, making it one of the most promising near-term technologies for future deep space missions. Breakthrough Starshot. Announced in 2016 with $100 million in backing from Yuri Milner and the support of Stephen Hawking, this was meant to be the boldest interstellar project ever attempted, a fleet of postage stamp-sized probes pushed by a massive ground-based laser to 20% the speed of light, reaching Alpha Centauri in just 20 years instead of tens of thousands. The plan called for nearly 1,000 tiny nanocraft launched together, accepting that interstellar dust would destroy many of them along the way, with the survivors beaming back the first close-up images of Proxima b, a potentially habitable planet orbiting our nearest stellar neighbor. The science was sound, but the engineering proved far harder than expected. Building a laser array powerful and precise enough to track a target moving at relativistic speed turned out to be a problem nobody could solve cheaply. In September 2025, it was reported that the project had quietly spent only about $4.5 million of its $100 million budget and is now on indefinite hold. It may never launch a single probe, but it pushed interstellar travel from science fiction into a real field of engineering research that continues today. If you're enjoying this video, hit the like button. We're aiming for 1,000 likes on this one, and every single one helps more people find this channel. And if you're not subscribed yet, hit that button and stick around. The future. Even with no propulsion breakthrough on the horizon, scientists continue designing what an interstellar probe might look like. NASA's interstellar probe concept aims to reach 1,000 astronomical units from the Sun using current technology stretched to its absolute limits, far beyond what Voyager has achieved. China's Shenzhou mission plans to launch a pair of probes toward 100 astronomical units by 2049, the centennial of the People's Republic, using gravity assists at Jupiter and a flyby of Neptune and Triton along the way. None of these will reach another star, but each one inches humanity closer to understanding what it would actually take. At current technology, reaching Alpha Centauri would take about 40,000 years. By then, the stars themselves have shifted position in the sky, and the nearest star to Earth may no longer even be Alpha Centauri. Interstellar travel remains one of the hardest problems humanity has ever attempted to solve, and also one of the most quietly persistent. Every generation of scientists picks the question back up, even when the last attempt fails.